5 children each light a candle at the same time. Lisa blows out the candles at different times. Now they look as shown in this picture. Which candle did Lisa blow out first? The one that is blown out first will have the least amount of time to burn. That means most of the candle will be still remaining. So basically, here I am looking the tallest candle. So if we look from the top, this is the tallest candle, right? Then D is the correct answer. The two markers with a question mark have the same value. So these are the two markers with a question mark. Which value do you have to use instead of the question mark so that the calculation is correct? So what should be the value instead of the question mark? So we can use algebra. Let me call this value x. Since they are the same value, this also has to be x. Then what I can do is I can collect the like terms together. So these are the numbers, I can collect them together. So this 20 plus 10 is 30, plus 10 is 40, plus 1 is 41, plus this is x and x, that is 2 times x, which we can simply write as 2x. And this has to be equal to 51. Now I want to find x, so first I subtract both sides. Subtract 41 from both sides, so this is going to be simply 2x is equal to 51 minus 41, this is going to be 10. Now I want to divide both sides by 2 so that I can find x. So x will be 10 by 2, so this is going to be 5. So question mark is x, that means which is 5, C is the correct answer. A black disc with 2 holes is placed on top of a dial of a watch. The black disc is turned. Which two numbers can be seen at the same time? Alright, so this is the black disc. One thing we have to notice is when I turn this disc, this distance needs to be maintained, right? So what is this distance? 1 plus 4 is equal to 5. So from 1 to 5 is a distance of 4, and that distance of 4 needs to be maintained when I turn the disc. So let's check one answer at a time. 4 and 9. So 4 plus 4 is 8. So 4 can be with 8. But it can also be this way. So 4 can also be distance of 1, 2, 3, 4. 4 can also be with 12. So there is one thing we have to keep in mind, because after 12, the count resets to 1. Alright. So then 4 can definitely not be with 9. So this cannot work. 5 and 10. 5 plus 4 is 9. It can be with 9. Or 1 plus 4 is 5, it can be with 1, but it's definitely not with 10, right? So 5 and 9, okay, we have already figured out that 5 and 9 are together, so this can work. Similarly, you can check these two, that this will not work, this will also not work, then C is the correct choice. Ali says, these 4 jigsaw pieces, which two can be put together to form this square? So this square, it has 4 smaller squares this way, 1, 2, 3, 4 smaller squares this way, and 1, 2, 3, 4 smaller squares this way. Alright, so we can check each choice one at a time. Let's check 1. So if I want to complete this square, 1, 2, 3, 4 this way, 1, 2, 3, 4 this way, I need a piece that looks like this. Right? Alright, so 1 and 2 looks something like what I have drawn in red. 4 also looks like that, so we can double check those. But 1 and 3 looks nothing similar to what I have drawn in red. In fact, 3 looks very similar to 1, so 1 and 3 definitely cannot be the correct choice. Now let's try 2 and 4. Now to match exactly, what you do is you can just use visualization, or if you are having a little bit trouble with that, I can just number it. Let me number these smaller squares. I can number it 1, 2, 3, 4, 5, 6. So these are the 7 smaller squares, and I have to maintain those order. So if I want to do with 2, this can be 1, below that is 2, left to that is 3, below that is 4, left to that is 5, above that is 6, above that is 7, but then I have this one extra piece, right? So this is going to overlap there, so 1 and 2 will not work. Okay, now let's check with 1 and 4, because 4 looks similar to what I need here. So this can be 1, 2, left of that is 3, below that is 4, left of that is 5, above that is 6, above that is 7, right? So this matches exactly that. So 1 and 4, then E is the correct choice. You can also, double check the other ones. So let's say 2 and 3. You can do a similar approach. If I need to complete 3, I need a structure that looks something like this. This looks similar, but again you can number it and make sure that it fits exactly. And 2 and 4 you can see that they look very similar to each other, so they definitely it cannot complete each other. So 2 and 4 are not going to be the correct choice either. So for this type of problem where you have to combine two pieces to get a third piece, there is another trick that you can use to solve it quickly. Notice that we need a complete square, that is 4 smaller squares this way and 4 smaller squares this way. That is 4 times 4 is equal to 16. That means we need 16 smaller squares in total. So let's count the number of smaller squares in each of these. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this has 9 smaller squares. This is 1, 2, 3, 4, 5, 6, 7, 8. This is 8. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. This is 1, 2, 3, 4, 5, 6, 7. This is 7. Right? So 1 and 2, 9 plus 8 is 17. So this is 17 total. So definitely that will not work. 1 and 3, 9 plus 10 is 19. So definitely that is not going to work. 2 and 3 is 10 plus 8 is 18, but we need 16. So this is 18, but we need 16. That is not going to work. 2 and 4 is 8 plus 7 is 15, but we need 16. So that is not going to work. 1 and 4, 9 plus 7 is 16. Right? So this is going to work. You have to be slightly careful with this trick though. There may be another structure that can add up to exactly a total of 16, but then after that you have to use the numbering to make sure that it matches exactly. The missing pieces match exactly. Maria switches the lights on and off according to the given plan like this. For how many minutes in total there are exactly 2 lights on at the same time? Alright, so we can simply count the interval. So in this interval there is only 1 light, so that is not going to work. Here 1 and 2. Okay, so this is going to work. Here 1, 2 and 3, that is not going to work. Here it's going to work. Here also this interval is going to work. Here this interval is also going to work. This 2, here 1, 2, 3 is not going to work. 1 and 2, this interval is going to work. Here there is only 1, here 1 and 2, 1 and 2. So total of 1, 2, 3, 4, 5, 6, 7 and 8. C is the correct choice. Christoph folds a see-through piece of foil along the dashed line. So this is the dashed line. What can he then see? Alright, so the thing to know here is, if I take a point here and if I fold it, right, along this, then it will follow a point that is equidistant from this dashed line. So that is, this distance has to be same as this distance. So this distance has to be same as this distance. So now let's try to fold. This point will fall here, and then this point is going to fall here, right? And then this line is going to be then this line here, right? Because every other point in between will fall on points in between. Similarly, this point is going to fall here. This one is going to fall here. Then I can join this two. Similarly, this point is going to fall here. This will be here. And this will be here. Then this will look like this. This point is going to fall here. This will be here. This will be here, this will be here, then I can join this. So this is 406. 406 is the correct choice. Anna has 4 discs of different sizes here. She wants to build a tower using 3. A smaller disc always has to lie on top of a bigger disc. How many ways there are for Anna to build this tower? So how many different ways? So notice that the discs are colored differently, but the color actually doesn't matter. What matters is the size. So just to make it easier to draw, I'll number the discs according to the size. The smallest one will be 1, the next bigger will be 2, then 3, and the biggest one will be 4. So I want to make a tower of 3 discs. 1, the second layer is smaller, the third layer is the smallest. Alright, so for the bottommost layer, I need to have the biggest disc. But the different possible choices are 1, 2, 3 or 4. But if I use 1 for the bottommost layer, there is no number smaller than 1. So this does not work. If I use 2 for the second layer, I can have 1 because that is the only number smaller than 2. But then I have nothing left for the third layer. So this also will not work. If I use 3 for the bottommost layer, I can have 1 or 2. Both numbers are smaller than 3. But if I use 1, there is nothing else left for the third layer. So this is not going to work. If I use 2 for the second layer, I will have 1 for the top layer. So that is going to work. For 4, for the second layer, I can have 1, 2 or 3. Now if I use 1, nothing else left for the third layer. So this is not going to work. If I use 2, for the third layer I can use 1, so this will work. If I use 3, for the third layer I can have 1 or 2. Both are smaller than 3, so these are also valid choices. So 3, 2, 1, 4, 2, 1, 4, 3, 1 and 4, 3, 2. The 1, 2, 3, 4. There are 4 different choices. C is the correct answer. Daniel sticks these 2 pieces of paper on this black circle. The 2 pieces of paper are not allowed to overlap. Which picture does he get? Alright, so let's check the answer one at a time. Here I can clearly see that there is an overlap here. So this is not going to work. Here, this white is a quarter circle and there is some overlap here. So it's not going to work. Here, the gray semicircle goes like this, so there is some overlap here. This is not going to work. Here, the gray is a semicircle, not 2 quarter circles, right? So this is definitely not the correct choice. Here, this is the gray semicircle, and this is the white quarter circle, and there is no overlap. So E is the correct choice. Using the pieces A, B, C, D, E, one can fill the shape completely. Which of the pieces lie on the dot? Alright, so these are the pieces using which we can fill this shape. We want to find out which one lies on this dot. So we have to use our imagination a little bit here. First we can see that this has to be the corner piece because there is one square stacked vertically, another one horizontally, and there is the only one that does that. So this has to be C. Here we see that the squares are stacked vertically, here also vertical, so these 2 may be coming from here, and sure enough, if I cut this like this here, this can be A, and then this can be B. So A, B and C are done, A, B and C are done. So here the squares are stacked horizontally, and I want something like an edge and a cut like this, so this can be my D, then this is sure enough my E. This is E. Then this dot is on piece E, then E is the correct choice. The 6 weights on a scale weigh 1, 2, 3, 4, 5 and 6 kg. Rossi places 5 weights on 2 scale pans so that they are balanced. Alright. The 6th weight is left aside. So this is the one. What weight is left aside? So what is this weight? So we have 1, 2, 3, 4, 5 and 6. 5 and 6, they are already placed there. Now whatever I put here, let me call it x. These two together has to be x plus 1, because this is already one more. Here is a 5, this is already one more, so this has to be one more than this, right? So then together is 6 plus x. Here 5 plus 1 is 6 plus x. Alright? So I have to find two numbers here that is more than one of the number here. The remaining will be left aside. So if we look carefully, if I combine these two, 3 plus 2 is 5, which is one more than 4. So this can be our x, this can be our x plus 1, and this is left aside. So this must be the 1 kg weight, right? So we can verify. 5 plus 2 is 7 plus 3 is 10, then 6 plus 4 is 10, so they are balanced, and 1 is left aside, is the correct choice. The diagram shows 4 cars, 1, 2, 3 and 4. The arrow shows where the cars move in 5 seconds. Which cars will crash onto each other? Alright, so let's look at the different answers one at a time. 1 and 2. So 1 moves here in 5 seconds, 2 moves here in 5 seconds. Next 5 seconds this will come here, and this will come here. In the next 5 seconds this will come here, and this will come here. But when it comes here, it would have already left, so they are not going to crash. Okay? 1 and 3. So 1 comes here, 3 comes here. Next 5 seconds, 1 will come here, and 3 will go here. But by the time it comes here, it would have already left. So 1 and 3 are not going to crash. 1 and 4. Okay, 1 is going this way, 4 is going this way, so they are definitely not going to crash. 2 and 3. 2, okay, so 2 is coming this way. In next 5 seconds it will be here. In the next 5 seconds it will be here. They are definitely going to crash, right? So it seems like D is the correct choice. But let's double check. 3 and 4. Next 5 seconds 3 will come here. 4 will go this way. But by the time it comes here, it would have already left. So again, they are not going to crash. Again, D is the correct choice. North of street A, there are 7 houses. Alright, this is street A, this is street B, north, south, this is east and west. North of street A, there are 7 houses. So this is A, this is the north area. So there are 7 houses. East of street B, there are 8 houses. East of street B, there are 8 houses. B, this is the east region, there are 8 houses. South of street A, there are 5 houses. This is A, this is the south region, and there are 5 houses. So there are 5 houses here. How many houses are west of street B? This is B, this is the west region. So how many houses are there? Alright. So how many total houses are there? If we take the houses on both north and south of street A, which we know, that will give us the total houses. So total houses is 7 to the north, 5 to the south. This is the total number of houses. Now I want how many houses are there on the west, but I know the number of houses on the east. So if I take away the total number of houses on the east, so that should give me the total number of houses on the west. So minus 8. So 7 plus 5 is 12. Minus 8 is equal to 4. A is the correct choice. In a queue in front of a ferry, there are 8 cars with 19 people in total. There are either 2 or 3 people in each car. How many cars are there with exactly 2 people in it? Right? So we have 8 cars. 1, 2, 3, 4, 5, 6, 7, and 8. So there are either 2 or 3 people. So let me just start with 2. So 2, 2, 2, 2, 2, 2, 2, 2. There are 8 cars. So 8 times 2 is 16 people are already in the car. There can be maximum of 3 people in each car. So I can give maximum of 1 more in each. I need a total of 19 people. I have accounted already for 16. So 19 minus 16 is 3 more people I need to account for. But I can give 1 more maximum to each car because there cannot be more than 3. So I can give 1 here, 1 here, 1 here. So these 3 cars have 3 each. Then the remaining 1, 2, 3, 4, 5 cars will have exactly 2 people. Then D is the correct choice. Six beavers and 2 kangaroos are standing on the fields in this order. So 6 plus 2, there are total 8. Of 3 animals in a row, there is always exactly 1 kangaroo. Alright, of any 3, there is exactly 1 kangaroo. For example, if I take 3, 4 and 5, there will be exactly 1 kangaroo. On which of these numbers stands a kangaroo? Alright, so let me start putting 1 kangaroo here first. So this will cover for 1, 2 and 3. For 2, 3 and 4 though there is no kangaroo yet. So where can I put a kangaroo? If I put it here, if I put a kangaroo here, if I take these 3 there will be 2 kangaroos, right? So I cannot put a kangaroo here. Similarly I cannot put 1 here because if I take these 3 there will be 2 kangaroos. So the kangaroo has to go here. Okay. So if I put the kangaroo there, so it covers for 2, 3 and 4. There is 1 kangaroo. 3, 4 and 5 also there is 1 kangaroo. 4, 5 and 6 also there is 1 kangaroo. But 6, 7 and 8 there is no kangaroo and I cannot use more than 2 kangaroos, right? So putting 1 at 1 is not going to work. So let me put a kangaroo here. So this will cover for 1, 2 and 3. There is 1 kangaroo. 2, 3 and 4 also there is 1 kangaroo. 3, 4 and 5 there is no kangaroo. So I need to put 1 kangaroo here. But I cannot put 1 here because then there will be 2 kangaroos in a row. Similarly, I cannot put it here. So the kangaroo has to go here. This will cover for 3, 4, 5. 4, 5 and 6 also there is 1 kangaroo. 5, 6 and 7 also there is 1 kangaroo. But 6, 7 and 8 there are no kangaroos because I have already used 2 and I cannot use more than 2 kangaroos, right? So putting at 2 is also not going to work. How about at 3? So 1, 2 and 3 there is 1 kangaroo. 2, 3 and 4 also 1 kangaroo. 3, 4 and 5 also 1 kangaroo. 4, 5 and 6 I need a kangaroo. Again I cannot put the kangaroo here because then there will be 2 in a row. Similarly I cannot put it here because then this will have 2 kangaroos in a row. So the kangaroo has to go here. If I put it here, so this will cover for 4, 5 and 6. 5, 6 and 7 also has 1 kangaroo. 6, 7 and 8 also has 1 kangaroo. So this is the correct placement at 3 and 6. So on which of these numbers stands a kangaroo? That will be 3 or 3 and 6. 6 is not one of the choice. Then C is the correct answer. Hanni wants to color in the circles in the diagram. These are the circles. When the 2 circles are connected by a line, they should have different colors. When they are connected, they should have different colors. What is the minimum number of colors she needs? So in real test, you will not have access probably to different colors. So we are going to use numbers instead of colors. So different numbers will represent different colors. And that way it will also be easy to do the work. So we can start with any node, I believe. So let me just start with 1. So this represents 1 color. So this is connected. So this has to be a different number. Let me say this is 2. This is also connected. So it has to be a different number. But I want to minimize the number of colors. So I can reuse 2 here because these 2 are not connected. Here I can again reuse 2. Here can I use 2? No, because these 2 are connected. So this cannot be same as these 2. So this has to be a 3. Now here it cannot be a 2, but it can very well be 1 because these are not connected. Here again it cannot be a 2 because this is connected. It cannot be a 3 because this is connected, but it can very well be 1. So the minimum number of colors I need here is 3, right? Now let me start with a different node. Let me just so these are the circles. Let me start, let's say for example here, I'll start with color 1 here. So it cannot be 1, so it has to be 2. This can also be 2 because these two are not connected. So this is connected to this, so this cannot be a 2, but this can be 1, right? I want to reuse because I want to minimize the number of colors. This node is connected to this, it cannot be 1, this is connected to 2, so it cannot be 2, so this can be 3. Now this is connected to 1, so it cannot be 1, but it can very well be 2, right? Because these two are not connected, so that's fine. So this cannot be 2 or 3, but I can always use 1 there. So again, I'm with minimum of 3 colors, I'm able to fill it, right? So then B is the correct choice. There is one more thing if you notice. So this is a triangle, right? So in this triangle, each node is connected to the other 2 nodes. So these 3 colors have to be different, right? So let me just draw it one more time. These are the, so this is a triangle, so they have to be different colors. So 1, 2, and 3, let's say. Now once I have those, so this is connected to 2, but is not connected to 1, so this can be 1. So this is connected to 1, 1, so this can be very well 2. Similarly here, this can be 1, this can be 2, right? So again, since this is a triangle, I need a minimum of 3. And once we have these 3 different colors, I basically just need to figure out if I can reuse those colors, and yes, I can. So minimum of 3 colors I need. A building block is made up of 5 identical rectangles. 1, 2, 3, 4, 5. How many of the patterns shown below can be made with 2 such building blocks? So two blocks without overlap. So one block has 5, so 2 block will have 5 times 2 is equal to 10, this smaller rectangle. So as a first pass, we can just count. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10. 1, 2, 3, 4, 5, 6, 7, 8. This is 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright. So I cannot definitely make this one, right? But the rest 4, let's check if I can use those building blocks. So here I can clearly see that, this is 1 and the other one is also identical block. This anyway I cannot make. Here, can I make with exactly 2 of this? Yes, I can. How about if so this is one of the block, the rest is exactly identical to that. Here, if I just cut it here, so 2 of this, that's fine. Here you can just split it in half, and the other is also identical. So yes, these 4 I can make with 2 identical building blocks. Then I have 1, 2, 3, 4. D is the correct choice. An underground line has 6 stations, A, B, C, D, E, F. The train stops at every station. After reaching the end of the line A or F, the train continues in the opposite direction. Alright, after it reaches here, it goes back like this. The train conductor starts his journey in station B. Alright, his first stop is in station C. In which station will his 46th stop? Alright, we are starting from here. So this is the first, second, third, 4. We return 5, 6, 7, 8, 9, 10. So the 10th stop will be here. So that completes one cycle. Similarly, if we count again, so the 20th stop will be there. Then 30th stop will be here, right? Similarly, 40th stop will be here, because that completes each 10 stop we are completing one cycle. So the 46th stop will be, so this will be 40, 41, 42, 43, 44, 45, 46. So this is going to be 46th stop. D is the correct choice. Now, if you noticed, for one cycle, it takes 10 stops. So we are doing 46 stops, right? There are 46 stops. So we are basically trying to divide 46 with 10, and we are trying to find the remainder, right? So the remainder is going to be 6, right? If we divide 46 with 10, so this is going to be 4, 6 over 10. So this is the remainder. And then we just basically count 6. 1, 2, 3, 4, 5, 6. We end up at D. Rebecca folds a square piece of paper twice. So this is a square piece of paper. It's folded once to get like this, and folded second time to get something like this. Then she cuts off one corner, as you can see in the diagram. This corner is cut off. Then she unfolds the paper. What could the paper look like now after unfolding it? Alright, so this is where we are cutting off this corner. So when I unfold it once, the cut here will be a reflection of this line, this cut, right? So this cut will be a reflection of this line, right? So this is the, when I unfold it once. When I unfold it twice, the cut on this side will be a reflection of this line here, about this line, right? So that is going to look, the reflection of this is going to look like this, and this is the whole paper. Okay, so again, when I first unfold, this line is going to be a reflection of this line about this line, and then when I unfold it one more time, this is going to be a reflection of this about this line. So we end up with something like this, a square paper with a cut in between. Then B is the correct choice. Three boys enter a room one after the other. Hermann is not the first. Alright, let me make a quick diagram. So this is the room. These are the three boys entering. This is the first, second, and third. Because oftentimes just making a diagram, helps a lot solving the problem. So Hermann is not the first. That means it can be either second and third. So this can be H, either 3 or 2. Felix is not the second, so Felix is not the second, so that means Felix is either 3 or 1, so this is F. Clemens is not the third, so Clemens is not the third, so it can be 2 or 1, so this can be Clemens, right? Alright, how many different orders are there for the boys to enter the room? Okay, so let me just start with H. So there are 3 spots, right? So this is again 3, 2, 1. H can be in 3 or 2. So let me start with H being at 3. If H is at 3, so I am starting here. F can be at 3 or 1, but H is already at 3, so F has to be at 1. Then next is F has to be at 1. There is only one spot left, so the C must be here, and for sure C can be in 2 or 1, so this is fine. So this is one configuration. The next one, so I started with H being at 3, but H can be at 3 or 2, so let me start with H being at 2. If H is 2, C can be at 2 or 1, but 2 is already occupied, so C has to be at 1, right? So C has to be at 1. Then there is only one spot left, so that must be F, and sure enough, F can be at 1 or 3, so F is fine here. Now, those are the only 2 configurations, right? There is nothing else is possible. So, how many different orders? So, there are only 2 different orders. 5 clocks are hanging on the wall. So these are the 5 clocks. One clock is 1 hour ahead, another clock is 1 hour late, and one clock is correct. Alright, so the time T is the correct. So one clock is 1 hour ahead, so another one is showing T plus 1. The other one is 1 hour late, so the other one is showing T minus 1. 2 two clocks have stopped working. Alright, which clock shows the correct time? So as you can see here, we need three consecutive numbers, t minus 1, t plus 1. So this clock is showing 6 o'clock, this is showing 2, this is showing 4, this is showing 3, this is showing 7, right? So the only three consecutive numbers here are 2, 4 and 3. So basically 2, 3 and 4, they are the consecutive numbers, and the middle one is the correct time. One is late, one is ahead, and the middle one has to be 3, right? Then, so this has to be 3, this is 1 hour ahead, 4, and 2, t minus 1 is 2, this is 1 hour late, so t is the correct one, then d is the correct choice. Adam has 9 marbles, Brenda has also 9 marbles. Together they have 8 white and 10 black marbles. Brenda has twice as many black marbles as white marbles. Alright, so in problem like this, it often helps to make a table. Let me say A for Adam and B for Brenda, right? And W for white and B for black. Alright, so Adam has total of 9, Brenda also has total of 9. Together they have 8 white, so here it is total of 8 white and 10 black, 10 black. Alright, so this is also B, this is also B, so let me just make a bold B here. This B is for black, this B is for Brenda. Alright, Brenda has twice as many black marbles as white marbles. Alright, so for Brenda, it has twice as many black marbles as white marbles. So let's say it has lowercase w white marbles, so it has twice as many black marbles, so it has 2w. Alright, so how many black marbles does Adam has? So we want to find this number. Alright, so this is the information that we have. Here we can see that w plus 2w has to be 9. So w plus 2w has to be 9. So this tells me w has to be 3, right? So this is 3w is 9. So w is 3. So this is 3. So this is then 3. This is then 6. So 3 plus what number is 8? 3 plus 5 is 8, right? 6 plus what number is 10? 6 plus, so this has to be 4, right? Then Adam has 4 black marbles. Then B is the correct choice. Elsa has two machines R and S. If she puts a square piece of paper into machine R, it is rotated like so. If she puts the piece of paper in machine S, it is printed on like so. She wants to produce the following picture. In which order does Elsa use the two machines so that she gets the picture? So we'll start with this. We want to end up here. First, notice that this dot is on this corner right now. So it has been rotated 1 time, 2 times, right? So we need 2 R's in the answer. So this is 2 R's, that's fine. This is 2 R, is fine. This doesn't have 2 R's, so this cannot be it. Similarly, this also doesn't have 2 R's, so that cannot be it. Next, we can check one answer at a time. So instead of drawing this complicated shape, I'll just put an arrow like this, okay? So let's say I start with SRR. So this is S, R, R, and then we'll see what we end up with. So if I put an S, S does a printing. So I end up with something like this. And then when I rotate it 1 time, so this gets rotated here. So this gets rotated 1 time here. So I end up like this. I rotate it 1 more time. And then I will end up with, so this will end up here. And this will be like this. But these are not the same, so this cannot be it. Okay, So let me try the next one. I use R, S, R. So I will use R, S, and R. So R, first it gets rotated. So I end up with this dot ends up being here. Then I print on it S. Then this is at the same position. When I print, it gets printed like this, right? And then I rotate it again. So this gets rotated here, and then this gets rotated one time. So this is same as this. Then B is the correct choice. You can just double check D and make sure that that is not the right choice. A teacher wants to write the numbers from 1 to 7 into these circles. He writes exactly one number in each circle. When he adds up the two numbers of the circles that are next to each other, he gets the number that is written between the two circles. For example, the sum of this and this is this number. Which number does he write in the circle with the question mark? So what number goes there? We know the sum of two numbers. So if I know one number, I also know the other number. So we can start by guessing this number. Let's say this number is 1. Then I know the next number, I know the next number, so on and so forth, and then see if it makes sense. So in this case, if it is 1, this has to be 5 because 5 plus 1 is 6. Then this has to be 4, 4 plus 5 is 9. Similarly, this has to be 4, this has to be 3, this has to be 6, this has to be 2, and then 2 plus 1 is 9, 2 plus 7 is 9. So I started with 1, I ended up with 7. It doesn't make sense, right? So it cannot be 1. Similarly, you can check the other numbers. I have already done it. Seems like this one works. So let's assume this number to be 4. So this has to be 2. 4 plus 2 is 6. This will be 7. This will be 1. This will be 6. This will be 3. This will be 5. 5 plus 4 is 9. So this makes sense. Then again, D is the correct choice. Actually, I wanted to check one more guess here to make a point. So let me check 2. Let me just change the color. Alright, so let's say I start guessing number 2 here. So then 2 plus what number is 6? 2 plus 4 is 6. Similarly, this will be 5. This will be 3. This will be 4. 3 plus 4 is 7. And 4 plus 5 is 9. 5 plus 3 is 8. 3 plus 6. So I started with 6. Sorry, I started with 2, ended up with 6. So that doesn't make sense. That is one thing. Second thing is, you see that I am using the number 4 twice here, right? So that also will not work because I can use each number only one time, right? So similarly, you can rule out the other choices and D will be the final answer. Maria colors exactly 5 cells of this grid in green. Then she has her 5 friends guess which cells she has colored in, and their answers are the 5 patterns A, B, C, D, and E. These 5. Maria looks at the patterns and says, one of you is right. The others have each guessed exactly 4 cells correctly. So the others have guessed 4 cells correctly and 1 cell wrong. Which pattern did Maria paint? Alright, so we can start assuming that Maria painted A and then C, check with B, C, D, and E. So let's say Maria painted A. Then if we check B, so this is correct, this is correct, this is correct, this is correct, this is wrong. So B has only 1 cell wrong, which is good. This is correct, this is correct, this is correct, this is correct, this is wrong, this is wrong. That means here there are 2 cells that are wrong, and that cannot be it, right? Because they have guessed exactly 4 cells correctly and 1 cell wrong. But this has 2 cells wrong. If we assume this to be correct, then again A cannot be the correct choice. Then similarly we can assume that B is the correct choice, so on and so forth. I have already done the checking and looks like E seems to work. So assuming E to be correct, then if I check with A, these two are the same. This and this is same. So this is off. That is off compared to B. So with B, these two are the same. This is same. This is same. So this is off. Here, these two are the same. This is same. This is off. Here, these two are same. This is same. This is same. This is off, right? So if we assume this to be correct, these 4 have exactly 1 cells off and 4 right, then E is the correct choice. Actually, one thing just occurred to me. Since we are comparing all the 5 patterns, we can ignore the ones that are common to all. For example, these 2 are common to all, so I can ignore those 2, those 2, those 2, those 2, those 2. So those 2 are common to all. Similarly, if you see, this is also common to all, so I can ignore this. Then what is remaining is just to check 2 cells. So if I just compare with these 2 cells, if I assume this to be right, here this is on the right position, this is off, this is on the right position, this is off, this is on the right position, this is off, this is on the right position, and this is off, right? Just to make the job a little bit easier.